All right. Well, we are recording now. Does that make it better? All right. So like I said before, we're going to be talking about the transversals and how they create those angle relationships whenever it intersects parallel lines. So the first thing that you need to make sure you understand is what a transversal is. So a transversal is a line that intersects two or more parallel lines. It's a line that intersects two or more parallel lines. So giving a little bit of space below here, I'm going to go ahead and draw two parallel lines, which should be pretty simple for you to do because you've got lined paper. Shouldn't be too hard to draw them. And again, parallel lines are lines that will never cross each other. You know, like so railroad track has parallel lines. Right now, if you're looking at the brick wall, you've got several sets of parallel lines, ones that are going horizontal and ones that are going vertical. And obviously the vertical lines are not parallel to the horizontal lines. Those are perpendicular to them. But we've got lots of examples of where we can see parallel sets of lines. The transversal is one that's actually going to cross over a parallel set of lines. Something like this. So this right here in the green is the transversal line. Now we've got what's called alternate interior and with alternate interior, it just means that it is inside the parallel lines or between. It's in between the parallel lines. And that it's on opposite sides of the transversal. So your alternate interior, they're in between your parallel lines, and they take place on opposite sides of your transversal. So for example, this one right here, this angle, is alternate and interior to this angle. You also have this one that's alternate interior to this one. So notice that I'm putting different amounts of lines in the angle. So here, when I put a single line, that means that they're congruent to each other. Where I see single lines, that's congruent. Where I see double lines, those are congruent. Now, both of these are interior. Both of these are on opposite sides of the transversal, but they're not alternate interior angles because they're both residing on the exact same parallel line. In order for them to be alternate interior, they have to be in between the parallel lines on opposite sides of the transversal and connected to opposite parallel lines. So this angle that connects to the upper parallel line has to be alternate interior to a different angle that's connected to the lower parallel line. Okay, so not every single set of interior angles that are on opposite sides of the transversal are considered alternate interior to each other. So be mindful of that. These are alternate interior. These are alternate interior. Okay, now, just like I said we had alternate interior, we also have alternate exterior. And just like interior means inside, exterior means what? Outside. So this is outside the parallel lines. And again, on opposite sides of the transversal. They're outside the parallel lines and on opposite sides of the transversal. So this measurement right here, I'm going to put a single line, is alternate exterior to this measurement here. So I'll put a single line. And like so, this angle, I'll put a double line, is alternate exterior to this angle with a double line. And like the video stated before, if you look at each individual cluster, you've just got a set of vertical angles. This interior angle is vertical to this exterior angle, so they both have that double line indicating that they are the same, even though one's in pink and one's in blue. Same thing here. This interior is congruent to this exterior because they are vertical. It's just one's inside, one is outside. That's why they both have that single line. Okay? Now, the last one that I want to talk to you guys about was what they said was corresponding. So the set of corresponding angles, that means it's in the same position in relation to the transversal. But one is interior and the other is exterior on different parallel lines. Okay, so to be able to discuss what was corresponding, I'm going to go ahead and label this angle X, and it's going to correspond right here. This one would also be an X. That would be corresponding. They would be identical to each other. Though one of them is on the exterior and one of them is on the interior, they both happen to be on the same side of the transversal, but they are in different locations for the parallel lines. One's on the top parallel line, one's on the bottom parallel line. But if you were to just go ahead and instead of having two sets of parallel lines, you were to go ahead and have this set of angles follow the transversal and overlap each other, they would line up. Does that make sense? Corresponding angles are going to line up. If you were to move it, if I could physically take this and move it all the way down to here, they would match up, being in the exact same position. So if this one was W, this one is W. If this one here is Y, this one here is Y. If this one up here is Z, then the bottom right is also Z. So they have to be able to move and overlap each other or match up with each other. They're just on different parallel lines. Are there any questions so far? Okay, now on the video, on the video, it shows that we had 8 angles, right? But how many actually different angles were there?
2.
Just 2. So when you have a set of parallel lines that's cut by a single transversal, even though it's creating 8 separate angles, you really only have 2 measurements, because 4 of the angles are the same and the other 4 are the same. So you're really only focusing on 2 types of angles. So let's make that a note. So if you only have one transversal, then technically there are only 2 angles. If you have one transversal, then technically there are only 2 angles. All the acute angles are congruent. All the obtuse angles are congruent. And furthermore, if you take that acute angle and you add the obtuse angle, it's going to equal how many degrees? 180. So if you take any one of the acute angles and add it with any one of the obtuse angles, it will equal 180 degrees. The only time that this statement is not true for having one transversal is if that transversal happens to be perpendicular to the parallel lines. And in that case, every single angle is going to be how many degrees? 90. And again, this only works if you've got one transversal. If you have more than one transversal, which we will show you that too, but if there happens to be more than one transversal, then this is no longer true. You won't have one type of obtuse and one type of acute. You're going to have a whole lot of different angle measurements. It's kind of like a puzzle. So of course we're going to start off real simple with just something easy like what they did in the video. So when you're ready, go ahead and switch your page to page 51. All right. Okay, so page 51. So draw a set of parallel lines and have a transversal that's going to intersect it. We're going to go ahead and label this A. This is B. This is C. This is D. We'll let this one be E, F, G, and H. And I'm going to go ahead and state that angle E is equal to 114 degrees. And I want to know, hey, what's the rest of the angles going to equal then? So this is, again, really, really simple. The first thing that you should do is take note of the fact that angle E, they're telling you is 114 degrees, So right here, I'm going to write 114 degrees. And based off of my relationships that I see, I should be able to fill in the rest of the stuff. Because I know that angle E is vertical to angle H, then angle H is also going to equal 114 degrees. So I'm going to write that relationship down. Angle E is vertical to angle H. Therefore, angle H equals 114 degrees. What other angles is related to angle E? What other relationship with relation to angle E do we see? Brent? A. Okay. What relationship does angle E have to angle A? Corresponding. Angle E is corresponding to angle A. So that means angle A is also equal to 114 degrees. Okay, there's one other relationship, one other angle that is a relationship with angle E. What other angle has a relationship to E? Sanaya? D. And what relationship is that, Sanaya? Well, angle D is not vertical to E. What relationship do E and D have? Alternate interior. Very good. So angle E is alternate. I'm just going to put alt. And then interior, I'm going to just put INT. Alternate interior to angle D. That means angle D is going to be equal to 114 degrees. Okay, so I filled up all of my obtuse angles. Now it's time to go ahead and identify all of my acute angles. And remember, to figure out our acute angle, what do we have to do? Destiny? Very good. So all we're going to do is subtract 180 minus 114, and that's going to be equal to 66 degrees. Okay, so that means all of my acute angles are going to be 66 degrees. Okay, so again, if I do everything in relation to angle E first, well, angle E is supplementary to G, or it's supplementary to F, so that would make both of those 66. G and F are equal to each other, so they both would have to be 66. C is going to correspond to G, B would correspond to F, or you could even say that G and B are going to be alternate exterior to each other. So there's a lot of different relationships that you could identify there. But angle B is going to equal 66 degrees. Angle C is going to equal 66 degrees. Angle F equals 66 degrees. And angle G equals 66 degrees. Now this is a very simple one. An extremely simple puzzle. You're not going to have them simple. Okay? We give you the basic idea, and you now need to be able to utilize that information and translate it to something more difficult. But again, it's all just a puzzle. I only gave you 2 angle measurements. But using those 2, you can solve for every single angle. Because again, it's just a puzzle. That's all it is. You just have to know what relationship exists to be able to translate from what you know to what you need to know. So let's start somewhere easy. Let's start up here. What's the first thing, if I cover all of this up and I just look at this, what's the very first thing I can tell without doing any kind of math? Seja. Very good. C happens to be vertical with 40, so therefore C is equal to 40. So let's go ahead and write that one down. So this measurement right here we know is 40. That means C is also going to be 40. So I'm going to write that. That angle C equals 40 because it is vertical to angle 40 degrees. Okay, so I'm going to go ahead and write 40 in here so that way it's part of it. Now, because I know that these are both 40, what else can I now figure out? Destiny? Angle A and B. How? Very good. Subtract 40 from 180. So that makes angle A and angle B 140. Okay? Angle A is equal to 140. Because it is supplementary to angle 40. And then angle B is equal to 140 because it's also supplementary. And because A and B are vertical. All right? So now we've got this portion done here. The thing that you need to focus on is what translates with that transversal. So remember, all of these angles are going to correspond with something that's down here. But you have to follow the transversal that it's connected to. But we have 2 separate transversals. So that means some of these angles down here are going to correspond to this cluster, and some of these angles down here are going to correspond to this cluster. The best thing I can tell you, because you can't exactly rewrite it, I'm going to highlight this transversal with purple. I'm going to go ahead and highlight my parallel lines with green. And just by doing that, by making that highlight, I can now see what's going to translate down. So let's start with like C. What angle down here is going to correspond to angle C? Correspond. Which angle is going to correspond to angle C? K. Okay, they are in the exact same position. Angle C and angle K are in the exact same position. So that means that angle K is also going to be 40 degrees. So angle K equals 40 degrees because it corresponds to angle C. Now, once I have one of these angles written down, I can now start filling in other parts, like angle D. I can fill in angle D because together K D and this right angle are going to form what kind of pairing? 180, supplementary. It's going to form that supplementary relationship. So I can actually solve for angle D because I know KD and the 90-degree angles is supplementary. I also know that, hey, if this is a right angle, then this together is also a right angle. So technically, K and D together are complementary. Does that make sense? If it's right here, it's right on this side as well when you connect them together to form that straight line. So we'll actually even focus on just saying it's complementary for K and D. So angle D is going to be equal to 50 degrees because angle K plus angle D equal 90 degrees. It's complementary. So I'm going to go ahead and fill in that angle D is 50 degrees. Now, once I've got that stuff in here, I can start filling in all my vertical angle relationships, right? So let's fill in the rest of these vertical angle relationships. What is H going to be? 90. So we'll go ahead and fill that in. Since this is 90, this is 90. What's F going to be? 40. It's vertical to K. So F is going to be 40. What's J going to be? 50 because D and J are vertical. So this is going to be 50. So we've got this done here. Now again, we can figure out what's left up here because we've got a set of angles that are going to correspond to stuff down here based off of this transversal. So I'm going to go ahead and highlight this transversal in a different color. I'm going to highlight this one in orange. So now I can see how they relate to each other. So let's start with something easy. Let's start with, D and I. Well, D and I don't have a relationship to each other. But G and D have a relationship to each other. See how they create this acute angle with the green and the orange? Here's also a green and an orange acute angle. So G and D would relate to each other. What relationship is that? Corresponding. Okay, so we know that G, angle G is going to equal 50 degrees because it corresponds to angle D. So angle G is going to be 50 degrees. And then once you've got one of those angles, you can figure out all the rest. Okay, if angle G is 50, what's angle E? 50. And if those angles are 50, what does it make the other two angles? 130. Very good, because you just subtract 180 minus 50, you get 130. So at first glance, it looks like it's going to be difficult, but all it is just piecing each part together as a puzzle. Any questions? Awesome. So you guys have an assignment. It is, it's printed straight from your workbook. All the questions that you don't need to do have already been crossed off. So any questions that do not need to be completed have been removed already. So please make sure you only do the ones that have not been crossed off. And it is due tomorrow.